types of differential equations. First order. So recall that we define the order of a differential equation by the highest derivative that's found in the equation itself. So the first call this technique or method or classification of a DE that we can solve is separation of variables. So at this point, I hope you can, to make it easier to follow along with the solutions, and maybe to help me is you can open a table of common integrals. Here are some of the common integrals that you need to remember. What's the integral of dx over x? Saan siya? What's the integral of e to the x dx? And of course, the integral of cosine x dx, integral of cosine 2x dx. Unsan yan ani nga mga terms. Also, if you can practice, try to recall the what do you call that technique? It's integration. Integration by parts. So in separation of variables, there exists a differential equation that might exist in this form: m dx plus n dy equal to 0, where m and n are actually functions. These could be functions of x or y, but in the case where m is only a function of x, we call it a of x dx, and this is capital B of y dy, then this is a differential equation that can be separated by variables. A first order differential equation that can be separated, that can be called, this is also called as variable separable differential equation. So variable separable equations are first order differential equations where they can be written in this form. So what do we observe here? We observe that one term has a dx component, the other term has a dy, and the coefficient of these terms are functions that exist only in x for this one, and functions that exist in some form dependent only on y. So we could have, for example, dy over dx is equal to 2y. So is this what can we observe here? Is this a differential equation? Yes, there is a derivative term. So on the left side of this equation, you have dy over dx. On the right side, we only have 2y. So the next question we want to know is, we want to observe is this a variable separable differential equation? Can we rewrite this equation in such a form that it looks similar to this one? Try to make, let's say, dx over dy is equal to 2y, and we want it to be of the form ax dx plus what did I use? by dy equal to 0. So how can we manipulate this equation that it will look similar to this one? So this, from just two terms, from a term on one side that's not equal to 0, you can transfer 2y to the other side. This becomes 2x over dy minus 2y equal to 0. So at least in the case of the number of terms, we observe that there are two terms here. A term based on dx and a term based on dy. Next, and the other side or one side of the equation equal to 0. So at least we've already covered the one side being equal to 0. The next thing we can do is multiply the entire equation with dy. So we now have dx minus, say it din siya. Oh yeah, this is correct. 2y dy equal to 0. The solution for the technique for variable separable is simply integrating the entire equation. So the solution is fairly simple. We just integrate the entire equation to get the solution to the differential equation. So what's the integral of dx? This is simply x. What's the integral of y dy? Of course, 0. Integral of y dy equal to 1. To y ang integral? Y squared over 2 equal to 0. So we now have a possible solution to the original differential equation. But this is, yeah, so it's that simple for first order variable separable equations. But this one, we mainly look for a solution where in this case it's dx over dy. We want to represent our answer in terms of either x in one side and all of the expressions on the other side. So this would be x 2y squared over 2, or cancel out ni siya, y squared. So x equal to y squared is a possible solution to this differential equation. If we substitute this here, just to check if possible ba na siyang answer, so we have d, x is defined as y squared equal to 2y. So dapat when we do the operations on both sides of the equations, they should be equal. On the right side, wala tay equation nga kanang lang i-execute, but on the left side natay derivative of y squared with respect to y, which will give us 2y equal to 2y. This proves that x equal to y squared is indeed a solution to the differential equation. Now, the thing about differential equations is there is more than one solution. That's why the term is a family of solutions depending on the equation itself. So there will be solutions where there are two forms of your function that will satisfy the differential equation. Any questions so far? Sa separation of variable. Variable separable. Hita ko lain example. May nindot, ha? So let's example 2. Was the term initial value problem introduced to you in calculus? So, in differential equations, there is a type of problem called initial value problems where, aside from aside from having the differential equation defined here, we're also given additional information, and it's sometimes presented to you, the student, in two ways. Could be presented like this: x is equal to 0 and y is equal to -2. So these are values to the variables that are known at the start. So that's why it's called initial value. So there are known values to our variables that is applied to the answer to our solution, answer to our differential equation. So whereas in the previous example, wala tayo initial condition, uh, we don't have to worry about anything. In initial value problems, you are given more information, so we can actually find, instead of multiple solutions, we can find just one solution to the differential equation. Actually, na ko'y kuwang din. This should have had plus C. Well, anyway, so another way to write this down is y of x is equal to a problem. So this is, it's usually represented as y of x equal to a value c. So in this case, it's when x is equal to 0, the value of y is equal to -2. So this is how we interpret this form of presenting the initial conditions. Since we're dealing with a variable separable problem, although this looks more complex than the previous example, we still follow the same general rules. No, we're looking for a way to express this dE as ax dx or plus by dy equal to 0. So we're close to there, except that for this term, for the first term on the left side, we have 2x times quantity y plus 1, which does not coincide with ax here. So we can do some manipulation to get the form 2x dx minus y 1 minus y dy equal to 0. So even with just this simple, what do you call this? Manipulation or modification, we can already see that this is indeed variable separable. It may be the case where you can also do, before you do the integration, in some cases, you can, of course, do it this way. You don't want to deal with negative signs. This is still essentially the same equation. Just perform the integration at that stage. So on the left side, it's x squared plus c. On the right side, what's one? What's y? 1 plus y. Y plus 1 din. So ito, y plus 1. Sa calculus, unsaon ni siya? How do you integrate y over y plus 1 dy. Integration by u substitution. Sige, unsa atong i-substitute, Clark? I think that's the correct one. U substitution. What we define as u? Y plus 1? Let's try. So, personally, no, kung maglisod, sakto ng instinct substitution, good. Means na may hinumduman. But okay ra na nga if just also be aware that sometimes you can make another substitution. But in this case, I think it's your instinct would be to make this 1 over u. That's a good instinct. So let's try ingon ani. So we let u equals to y plus 1. You also need du to make the substitution complete. So the derivative of this one is dy. Uh, sakto? Derivative of 1 is y. Pero unsay mahitabo sa y? If mobalik ta sa substitution. So in this case, this becomes integral of y u d o u. Y equals to u minus 1. U minus 1. So nasaka ang expression. So this now becomes y du minus du over u. No? Pwede ba? Pwede ba? So this becomes u minus, what's the integral of 1 over u? Ln of u. We do back substitution. This is y plus 1 minus ln of root value y plus 1 a plus c. So we can have the constant here be combined with this unknown arbitrary constant due to the integration. So we will end up with y plus 1 minus ln of y plus 1 so if we want x squared equal to y plus 1 minus ln of y plus 1 plus c. So this is a solution to our differential equation. However, delete ni siya. Again, we want to have our, I think pwede man sad gid siguro, no? We can have u, balik ko sa substitution, equal to y plus 1 raised to negative 1. This could be another solution. I guess you would still get the same answer. Okay, so this is a solution. The next thing we want to do, since we know the values for x and 0, so that we can define c. So that's where the initial values of our problem, dili ba ma-appeal ang plus 1 sa no? Yeah, we can do that. So the next step, if it's an initial value problem, is to substitute the values for x and y into the solution. This means 0 squared equal to -2 minus ln of -2 plus 1 ln of -1 plus c, which is c is equal to 2. Negative ln y plus 1 y plus 1. About as a c, which makes the final answer squared equal to y minus ln of y plus 1 plus 2, the absolute solution to the differential equation. Earl, unsa asa na nga part imong pasabot nga y minus ln? Ka-insert mag equation sa kwan. Dili. Okay. Sa pa man ha. So the first type of differential equation for first order, ang pinakauna nga first order differential equation na this is the first type, our first problem for DE. Any other clarifications? Earl, what do you mean sa kaning, sir, dili na y minus y plus 1 question mo. Asa dapit? Sa ganina, sir, katong naapay plus 1. Sa kani, dire? Dire dapita? If i-add ang constant plus c na lang siya. Oh, moto nasayop ko ganina. Sakto ka, Earl. Pwede ra gyud to siya, mga plus c. So, let's do one more example. Okay ra, so far, if you easy ra gyud siya. That's how we identify if a first order differential equation is variable separable. Katur gyud ato ang concern. From exercise, let's have 2xy y prime equal to 1 plus y squared. Maglisod na siya. Is this a variable separable equation? Of course, this could be rewritten as 2x y. Namoy prime notation sa differential equations, no? Differential calculus. So this is dy over dx equal to 1 plus y squared. PD ba ni? Then we have this. So you can check. We want to have dx to be a term, not in the denominator. So 2xy dy equal to 1 plus y squared dx. This one, nakapay y. So we can cross multiply, no? We can have 2x to the right. So we can have y dy over 1 plus y squared equal to dx over 2x, which, if we, just to save some space, we further, just to make this clear, this could be equal to 0, which again is as close to what we were looking for in a of x dx plus b of y dy equal to 0. If masuwat nimo ang DE in this format, then we can call it a variable separable a differential equation. So which at this stage by our manipulation is indeed variable separable. What we can do next is to start the integration. We just simply integrate the entire equation. Since integration is linear, we integrate it by term. Integral of y dy over 1 plus y squared minus 1 over 2, the integral of dx over x equal to 0. So kani siya, dili kayo problema, no? So kani, pwede gihapon ta mag-substitution by u. So ayan na to. Pwede ba? 1 plus y squared du is equal to, say, 2y. Yeah? 2y dy. Sakto ba? 2y dy. Pwede ta mag-retcon, no? For later na lang. Ayaw na lang. Libog na. So 2y dy, if you look at the original, wala tayo 2. So we can have du over 2 equal to y dy. So we have direct substitution. So ano siya? How do we annotate this to be? May pag-green ko na. Anyway, for this term, this is our partial compartmentalized solution. We can have integral of so y dy is equal to du over 2. Ang ubos is equal to u, which is, then write 1/2 outside. Integral of du over u, which is 1/2 ln of u, which then becomes 1/2 ln of 1 plus y squared. So partially compartment solution manata, and we go back. So this now becomes 1/2 ln of 1 plus y squared minus 1/2 ln of x equal to 0. You can simplify this by multiplying 2 to the entire equation. So mapapas ang 1/2, cancel ni siya diri, cancel ni siya diri. The right side does not pose an issue. So we end up with ln of 1 plus y squared minus ln of x equal to 0. You still remember the method of removing a natural log from an equation? So tawagan. What's the term for that one? Complement ba na? The direct para cancel out ba sa ln sa natural log? Nakasuway mo, nakaagi mo na sa natural log. If it's the natural log, one way to remove it is to, e. Gamiton ang e. Ano mo sa meaning sa di bitaw. That's the full name of e. It's a function, di ba? Euler's? Euler's function din na ang tudlo. Oh, hinoon niya. Pwede ra sa Euler's. So, when you apply Euler's to an equation, what happens? How do you do it? What's the proper uh, for an equation? It's also linear, no? So we apply Euler's to both sides of the equation. So this becomes Euler exponential function ln 1 plus p minus ln ng x equal to e to the 0 the left side becomes e to the ln 1 plus y squared absolute value times e to the negative x. Since di man cancel out, ito ba? 0. Ito siya. This become 1 plus y, cancel out, squared, x to the negative 1 equal to 0. Ini siya 0, be 1. This become x is equal to 1 plus y squared. This is our answer. In terms of x, it's in terms of y, should be y is equal to x minus 1 square root. Yeah, sahip ko Mendoza. Thank you. Nindot na ni Jamboard, no? Kay nahuman tulon kang example sa akong mahatag. May questions? Nausig atong kuan, no? Anyway, if you don't have any questions, it's already 2:56. Is it okay if we meet on Wednesday this week?
Pwede
Yes,
ra, sir.
sir. 1:30. Okay. Sige, we'll continue on Wednesday for the rest of the first order differential equation. Same link, sir, or new? Lance, Alazas, wait lang for an announcement. Depende kay hitabo na. I don't know what happened good pag alas 2. I was sick. Just wait for announcement na lang. I think I'll make a new one just in case. So I'll set up early, mga 1:15. Akong testingan ang tanan-tanan. Pag-share, webcam, microphone. Oh yeah, kung ako na-upload to Canvas, no? Because I will upload it in Canvas eventually. Sir, sorry, sir. Ikan karon siga. Okay, Mr. Chia. Try to upload the recording. Thank you sa nag-record kalimot ko record sa Google Meet. I usually make my own recording but since I made a restart ganina, kalimot ko kuan. I'll post this on Canvas. I'll make the modules there na. I'll also post na the syllabus. Yeah, apil na ang last week. Seva? I don't know. How do you pronounce your first name? Raven. Okay. Raven, tanan na ako ang, I think I have 3 recordings. I'll upload it in YouTube and then put the link in Canvas. Thank you guys. Have a good rest of your afternoon. We'll start early.